Assalamualaikum. My name is Shehbaz and my ID is 008. Today I am going to tell you about my practical, and my practical topic is determination value of lambda max and graph of potassium dichromate solution using spectroscopy. First of all, we will see the objectives. In this determination of wavelength of maximum absorbance, verification of Beer-Lambert's law, and the introduction is a spectrophotometer is an instrument that measures the amount of photons. As we know that the spectrophotometer measures the amount of photon, the intensity of light, which is absorbed after it's passed through a sample solution. With the spectrophotometer, the amount of a known chemical substance can also be determined by measuring the intensity of light detected. Depending on the range of wavelength of light source, it can be classified into two types: UV visible spectrophotometer, and second one is IR spectrophotometer. In UV visible spectrophotometer, it uses light over the ultraviolet range 185 to 400 nanometer, and visible range is 400 to 700 nanometer of electromagnetic radiation spectrum. And in infrared spectrophotometer, it uses light over infrared range 700 to 15,000 nanometer of electromagnetic radiation spectrum. In visible spectroscopy, the absorption and or the transmission of a certain substance can be determined by the observed color. For instance, a solution sample that absorbs light over all visible ranges transmit none of visible wavelength. It appears in black in theory. On the other hand, if all visible wavelengths are transmitted, the solution sample appears white. If solution sample absorbs red light, it appears green, and if it absorbs green light, it appears of red. Visible spectrophotometer use a prism to narrow down a certain range of wavelength so that the particular beam of light is passed through a sample solution. Next, we will discuss about Beer-Lambert law. Beer-Lambert law is also known as Beer's law. It states that there is a linear relationship between absorbance and the concentration of a sample. For this reason, Beer's law can only be applied when there is a linear relationship between Beer laws, as it is written as A is equal to epsilon r multiplied by LC. As we know that A is the measure of absorbance, epsilon is the molar extinction coefficient or molar absorptivity. L is the path length. C is the concentration. The molar extinction coefficient is given as a constant and varies for each molecule. Absorbance does not carry any error since absorbance, epsilon, and path length are known. So we can calculate the concentration C of the sample. For this practical, the apparatus is test tube holder, main cylinder, pipette, flask, spectrophotometer, and the chemicals used in this is potassium dichromate water. Procedure: in first step, we will prepare 100 milliliter of a stock standard solution of 0.001 molar of potassium dichromate. Accurately weight 126 milligram solid potassium dichromate, transferred quantitatively to a 100 milliliter volumetric flask and filled to the mark with water. This is the stock solution. In second step, we will prepare 6 standards in 100 milliliter volumetric flask with the concentration of 0.004 molar solution, 0.0002 molar solution into second tube, and in third one we will prepare 0.001 molar solution, and in fourth we will prepare 0.0005 molar solution by diluting the stock solution prepared in step 1, and this is termed as serial dilution. And in second step, we will rinse off the cuvette with distilled water and fill it with water. Put the cuvette in the sample compartment. This is the reference solution. Set the wavelength to 400 nanometer, then set the absorbance to 0. In fourth step, rinse a second cuvette once with distilled water and once with standard solution. Then fill it with standard solution. First, with place the cell in the sample compartment. Measure the absorbance at 410 nanometer. In fifth step, Repeat the procedure. Step above third to fourth time, 3 to 4 times for the two covers at wavelength 420, 30, 40, 450 to 600 nanometer. First setting A is equal to 0 for the covered with water, then measuring A for the covered with 0.001 molar potassium dichromate, recording the absorbance at each wavelength. Recording table. In sixth step, we will draw a graph of absorbance A versus wavelength and determine lambda max value. In second step, we will set the wavelength of at 550 nanometer, place the cover with distilled water in the cell compartment, and again set the absorbance to 0. In a step, measure and record the absorbance of each of the 6 standard solutions, starting with the most dilute standard. After each measurement, reduce the cover with standard next standard not with distilled water. In ninth step, we will draw a plot having x-axis as concentration and y-axis as lambda max value. In 10th solution, we will use the bare lambda to calculate the value of epsilon value of potassium dichromate given the cell width to be 1 centimeter. In this is the table. These are the observation and calculations, and this is the graph versus absorbance and wavelength. In this and in next one, we will calculate a different concentration at, and in this table we will prepare at lambda max value is equal to 550 nanometer, and the result is that the result of the experiment should greater the concentration, greater will be the absorbance. The value of absorbance increase as we increase the concentration of potassium dichromate at lambda max is equal to, for example, it is equal to 550 nanometer. Result of the experiment verifies Beard lambda law. In discussion on the graph, tangent line does not pass exactly through 0. This is expected. It may be due to statistics of the point data, which are not equally on the straight line due to random errors in the concentration and or the absorbance reading, or to the fact that there is a remaining solution absorbance for the standards. Finally, trend line slope is the molestation coefficient. The equation y is equal to 0.1609x minus 0.1293. For this application should be read as A is equal to epsilon c plus constant with the constant is equal to intercept. And this is the reference from which we will collect the material. That's all from my side. Thank you so much.